worth our time. All right. Yeah, so this is just hitting the buttons on the calculator, but it's a little harder. So can you type that in real quick and tell me what you get? If you have one of those calculators where everything's on one line flat, like the older kind, then you're going to have to use parentheses around the numerator and denominator, right? So if... Uh-oh. My pen not working? Uh-oh. My pen's not working? I can't believe it. I'll have to plug in over the whole weekend. All right. I don't know why that would be. All right. So, yeah, so you've got to put parentheses around the numerator like that and denominator if your calculator does it on one line. If your calculator makes fractions, then great. Just type it in like it looks and won't be any problem at all. But if you have the old style that lays everything flat, then you're going to have to put parentheses around the numerator and denominator, like so. So, has somebody got an answer? What is it, 2.30. Give me one more. 2.303? You guys getting that? That good? All right. So we have several parts to it. This will be really good. We'll spend a long time on this question. So, all right. So here we go. Basically, it's got 5 parts remaining, and they're each huge. So, so these problems are really, really big. They're going to ask us to first off find the domain of that function, then graph it, then find the inverse function, then graph that thing. So it's a bunch of parts. All right. So first off, can you find the domain of that function? How do you find the domain of a log function? What's that?
X's little world.
Yeah, right? So what do we learn for domain for ln or regular log? Any kind of log, right? The inside has to be greater, no, not equal, huh? Just greater than 0, right? The inside of a log can never be negative, huh? Remember that? It's almost like inside of a square root, huh? Right? Inside of a square root can be 0, though. But the inside of a log cannot be negative. So you just take the inside and you go, all right, x minus 3. You got to be greater than 0, which means x has to be greater than 3. So that's the domain. We good so far on that? Not a big problem there, right? Next, we have to graph the thing. So x greater than 3. Let's go to the graph now. All right. So now for the graph. So how do we graph it? So let's make an XY chart, like we always do for our graphs, and we start by finding the center point. How are we going to find the center point? Make the inside of make x's little world 0. Right? Isn't that what we do on all of them? If somebody gave you the square root of x minus 3 or whatever, you'd plug in x is 3, right? Because that would make x's little world 3. Oops, I can't erase. There we go. Anyway, so what am I going to plug in here? 3? Right? So y equals natural log, plug in 3. Y equals natural log of 0. What's that? You guys got your calculator? Yeah, that's what we just talked about. You can't put, just probably what's on your mind. You're probably thinking, Mr. Herron, didn't we just say you can't make the inside of a log 0? Exactly. Right. If you're thinking that, you're totally right. This is a no-fly zone. You can't go there, huh? But it's really important that we find that point because you know what's going to be there? What usually does it mean when you can't go there? Vertical asymptote. Yeah, log graphs have a vertical asymptote. So that's going to mean at x is positive 3, 1, 2, 3, there is a vertical asymptote at 3. Sorry, my graph's so there. All right, so that good? Does that make sense? That's a vertical asymptote. We're going to see that logs are exactly the inverses of exponentials. That's what they are. So it's exactly the opposite. Remember how we did our inverse functions? In just a minute, we're going to find the inverse function of this, and it's going to be an exponential function. They're opposites of each other. That's what logs are. I don't know if you know that. When I was in pre-calc and calc, If somebody had stopped me on the street and said, hey, what is a log anyway? Logarithm, I would have said, I have no idea. I can crank them out and follow them rules, but I don't not even know what this thing is. So what is it? It's the inverse of an exponential. It's the opposite. Logs are opposites of power functions. They're the opposites of exponentials. And we'll see in this example that perfectly. Anyway, so my point in saying all that is, remember exponential functions? What kind of asymptote line do exponential functions have? Always horizontal. So no surprise, logs, the opposite, the inverse, have vertical asymptote lines. So the log, wherever you make the inside 0, that's where you're going to have your vertical asymptote line. Okay, so now what do we do to find the other point? That's the center point. It's not really a point, but it's kind of the center. And so what do we do to find our other point? We add 1. So plug in 4. When you plug in 4, what do you get? I'm kind of running out of room here. You plug in 4, you get y equals natural log. Well, I don't really have room down there. I'll do it up here. Y equals natural log of 4 minus 3, right? Natural log of 1, which your calculator will tell you is 0. So that means over 4 up 0. There's that dot. We good so far? Let's find one more dot. Because really we have only got one dot. We got a dot and a vertical line. So it would be good to actually just do one more. Does that make sense? We always like 2 dots, don't we? So the center dot turned out to not really be a dot, but a vertical asymptote line. So let's find 2 dots. So I added 1, plugged in 4, got 0. Now I'm going to add 1 again, and that'll be 5. And so y equals natural log of 5 minus 3, which is natural log of 2. And that's just hit the buttons on your calculator. Somebody got that? Is it 0.6 or 7? So we'll just say 0.7. So that's about as accurate as I can graph anyway. Let's just say 0.7. So that means over 5. Here's 5, right? Here's 4. Over 5 up. Oh, we better get this out of the way. Over 5 up 0.7. Where's that? Well, here's 1. So 0.7 is just, say about right there. Over 5. Is that on the screen? Barely. Over 5 up 0.7. And, okay, so we have our 2 dots. Everybody with me? We've got an over 4 up 0 dot and an over 5 up a little bit dot, 0.7. Like that. And we got our vertical, right? And what do they always do at the vertical? What do graphs always do at a vertical? They either take a dive or take a climb, right? What's this one going to clearly do? It's going to take a dive. There's our graph. That's the graph of the natural log of x minus 3. Does that make sense there? Everybody good with that?
That's the exponential graph goes this way, right? That's the
Yeah, good observation, Robert. Yeah, exponential. Well, this graph is noticed as concave down, huh? It's like a bowl turned down. It's slow growth, right? You get more into that in calculus. Exponentials are bowls turned up, fast growth, aren't they? It's exactly the inverse of exponential, which we're now going to find. So it's a good observation. So everybody good with how you? So this is the last. For this test anyway, the last of the graphs you'll have to do on this test. So probably on part 1 on Wednesday, when you take that, I don't exactly remember, but I bet there's one log graph, one exponential graph, and one other kind of graph. Maybe x squared, because that was new, where you have the 2 branches side by side instead of diagonal, right? Probably one of those. So for sure a log graph, for sure an exponential graph. So how do you do log graphs? When you want to file away, put on your 3x5 card, vertical, they always have a vertical asymptote. Exponential graphs always have a flat horizontal asymptote. Log graphs, any kind of log, not just natural log, but any log, always has a vertical. And how do you find it? Well, you just do the normal thing. Just plug in whatever makes the x's world 0, and that will be your vertical, because you can't have 0. It's an error inside a log. It'll tell you, oh, yeah, that's my vertical. So you put your vertical in, just add 1, plug them in, use your calculator, get a couple of dots, and it's usually going to dive there. Sometimes it'll climb. We would have known that if this dot was higher and that was lower, then it would have been climbing there. But it's always bowl turned down. I will take off if you make this bowl go up, because that's not a lot. I think up 1 point, maybe 2. But it's got to be bowl turned down. So logs are slow growth. Exponentials are fast growth. Was there a question, Seth? Yeah, exactly. Yeah, that's good hearing. Yeah, so you want to have on part one a scientific calculator, right? But you can't use your cell phones, right? You want to have a calculator that's not, that's not your graphing. You want to have a scientific calculator for part one on Wednesday. That's right. All right. So let's go on now. There's much more. There's about half more to this problem. So now, having done the domain, the graph, then if you want into part C, it would say find the inverse. The inverse function. We did that about a week ago. Remember how we find inverse functions? Step one, we switch or invert x and y. Step two, solve for y. Remember all that? All right, so what's my original function here? It is y equals natural log of x minus 3. So step one, I'm going to switch x and y, like so. And then I'm going to solve for y. Everybody good? For step one, I mean? And then solve for y. So now we're going to solve for y. So y is over there saying, I want to be alone. Let me bring it up here. So x equals natural log. Y is saying, I want to be alone. So what do we do? So this is the tricky step. Everybody dialed in? You look dialed in. Are you dialed in? Don't miss this. This is the step that stumbles a lot of people. How do we get that y alone? How do we get it alone? Here's what I see a lot. You can tell by my tone. This is wrong. Don't do this. But I see this. Now divide by the natural log on both sides. No. Really important that you see that as craziness. Do you see that as craziness? If you're not seeing that as craziness, let me help you see that that's crazy. This is not multiply. You want to make sure you look at natural log or regular log or in trig, sine, cosine, tangent. Those are functions. They're not multiply. This is a toaster. This is plugged into, that's why I use the analogy of it's like plugged into the toaster. It's not multiply. This is like f of y minus 3, kind of. But it's natural log instead, or sine or cosine or tangent. Those are all functions, right? And the y minus 3 is plugged into the toaster there. That's not multiply. I know it's confusing because there's parentheses, and we often think parentheses mean multiply, but they don't mean multiply here, do they? They mean plugged into the toaster, plugged into the function, huh? So we can't just divide off that natural log. It's not multiply. So dividing won't handle it, right? It's a function. So what do we do then? How do we get rid of that natural log then? We got to get rid of that natural log because the y is in there, and we got to get the y out of there because we're trying to get y alone. So we do have to get rid of it somehow, but not by dividing because that's not multiply. That's plugged in. So what do we do then? How do we get rid of the natural log?
Exponential form.
Remember, we learned what I called the golden rule of logs? Remember when we first started logs, I think it was Thursday, Wednesday, whatever. What's the main thing you always do with logs? When you gain or lose a log, that's what we want to do here, right? We want to lose that log. Natural log, right? It doesn't matter, any kind of log. When you gain or lose a log, what happens? I thought I made it like a catchy song. It's just been ringing through your head all weekend, right? The bass stays the bass. The other two, see, I'm not a singer. You can tell that it's good I can do math because I can't sing. Anyway, the bass stays the bass. The other two switch. That's the golden rule of logs. Make sure you know that. So what bass? I don't see any bass. What's the bass? Well, E, good. Remember, if it's regular log, it's a 10. If it's ln, it's an E. For the base. You got to know those two. Every log has a base. He's just not showing his base, right? ln it's E. Regular log it'd be 10, right? All right, so when you lose the log, bye-bye log, the base stays the base. The other two switch. That's just fundamental. If you don't know that, you're going to wipe you out in like 5 problems. You got to know that for sure. So the base stays the base. The other two, what other two? Everything else. The y stuff, the x stuff, swap-a-roo, right? Instead of e to the y stuff, it's e to the x, and the y stuff goes to the other side. There we go. Struggling with my finger here. All right, so we good to there? Bye-bye log. We lost the log. Much easier now. Now what do we do to get y alone? It's child's play now. Just add that 3 to the other. Whoops, come on. Add that 3. I'm just scribbling everywhere here. Add that 3 to both sides. And we get y equals e to the x plus 3. Look at that. And we did the normal steps for inverse. Switched x and y, solve for y. For a log, and what was the inverse? An exponential. So there it is. That's what I was saying. Exponentials are inverses of logs. That's why we have them. Why did we make them up? And we did make them up. Logs are made up. All of math is made up to help you do things in real life, right? So logs are just made up because they're the inverses of exponentials, and we need them to solve exponentials, which we'll see even today. Seth?
Where does the x go to the exponential?
Where does the x go? That's what happens when you lose the log.
It just happens.
Yeah. So, well, yeah, and that is the golden rule of what happens. Yeah, so you want to know. So in my saying, the base stays the base. Catch the significance of those words. I'm not just saying goofy sayings. Every word matters for what you should do. So base stays, what does that mean? Base, it means it stays low, which means it's got something on it. So notice the common mistake I see students make who haven't practiced this enough is they put the x beside it or something. And they're missing the significance of my words. E's not a base if you do that. X is just beside him. Not a base. A base is something that's low down, it's got something on it. Right? So that's why I'm saying that saying. The base stays the base. Meaning the E's got to be low, it's got to have something on it. So right, so it was the y on it, right? Remember the E is low down, and look, the y was on it. They swapped. Now the x is on it. So there was always something on it. The base stays the base. It always had something on it. Now it has the x instead of the y. It doesn't look like I'm answering your question, Seth.
No, I get it now.
That makes sense?
What process?
Yeah. Is that good? So does that make so now we got to graph that thing. So the last part is they say, okay, you found it. This is the exponential here. Now graph that thing. So y equals e to the x plus 3. So let's now graph that thing. So y equals e to the x plus 3. How do we graph it? You guys are pros, I hope. I hope you're pros now at graphing exponentials. You tell me. What's step number 1 for graphing an exponential? So let me write a note here. Good job, Robert. Graph expo. I can't spell and talk. Exponential. There it is. Okay, graph exponential. Step one is horizontal as, right? You don't start with the table. It's the only time we don't start with the table in all of our graphing, huh? So you really have to be intentional. Put that on your 3x5 card. When you're graphing exponential, step 1 is the horizontal, which is what? What is the horizontal?
-3.
It's just positive 3. It's just that number off to the right. So whatever number's added or subtracted off to the right. So horizontal asymptoted up 3. Boom. Whoops, supposed to be dotted, huh? Boom, 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 boom. There we go. Horizontal asymptote at up 3. We good with that one? That's always step number 1. Then do the table thing. So you want to intentionally remember all the rest of the graphs, we just start with the table right away. But for exponential, you start with the horizontal asymptote. Then step 2, make the table. What am I going to plug in? What's going to zero out the x zone to be to 0, huh? So y equals e to the 0 plus 3. What's e to the 0 plus 3? 4, because e to the 0 is 1. So over 0 up 4. No surprise. We're used to the dot. It's almost always 1 above the horizontal asymptote, huh? If you did your homework in the exponential section, you're used to that. It's just 1 above. All right, then what do? We add 1. This is all the same stuff. Add 1, plug it in, e to the 1 plus 3. Just use your calculator. 2.7, so 5.7. So 5.7, just under 6. This is 4, 5, 6. So over 1. I hope it doesn't mean. I really want to go back and do one more of those. Anyway, all right, let's do what we can. All right, so I'm going to skip. There's like 7 of those, though. And they're super valuable. You need to do those. That's how math is learned. There it is. There it is. Last night, I spent hours with my busy girl doing long, difficult math problems. Anyway, there was only 8 of them. It took us like 2 hours. And I know I'm a math teacher, so it's going to be worse. That's what I had to do. It's what I had to do when hours. So let me just encourage you, don't shortcut that. Spend hours on those 7 problems. Learn how to fight. See, those 7 problems have almost like everything we've done. You can master those 7. You are in such good shape. but it'll take a lot of time. But master those. Look, because they have inverses, they have graphs of exponentials, graphs of logs, the base stays the base thing. And almost everything we've done is in those 7 problems, or however many it is. Super long, super valuable. All right, this will be quick and easy. How do you solve that thing? How do you solve a log? Yeah, you lose it. Bye-bye. What happens when you lose a log? Base stays the base. Who's the base? 3. He's the low down. He continues to be low down. The other 2 switch. 3 to the 4. X goes over there. Then just hit the buttons on your calculator. What's that, 81? Because it's 99. X is 81. Easy, right? So remember that fundamental, the golden rule of logs. When you gain or lose a log word, cross one out or put a new one on that wasn't there. Base stays the base. Other 2 switch. Fundamental. What do they want? It is the same thing. Yeah, so same basic thing. Right, solve it, lose the log, base stays the base, other 2 switch, x squared, 400. So you get to there, you're supposed to root it, right? So root it. Oh, it's just 20, isn't it? Yeah. I wasn't thinking, I thought it was going to be something ugly. It's just 20. Now, you're supposed to do plus or minus, right? When you put a roof on the house, up and down the ladder. But a base can only be positive. You can't have a negative base. There's no such thing as a log with it. Bases, positive only. Remember, logs, you can't have negative bases. You can't plug in negative things. So you just keep the positive 20. All right, that's easy. Let me show you what I mean. Okay, so natural log e to the x. Now, is this e lowered down right now? No, he's on the level, so he's not the base. There's another e hiding, right? There's another one, and he's hiding. He's right here, and you need to see him. Does that make sense? Every log, regular log, natural log, whatever, has a lower down base, and if it's not showing, put it in there. Ln it's e, regular log it's 10. Put it in there. Don't confuse that with the other e that's there. That one's on the level. On that, Seth?
No, why did we put the 10 in the last ones?
I don't remember. Didn't they have their own base? Yeah, that one already had a base. So I'm saying when it's not showing. See, that last one was showing a base, x. Does that make sense? So 10's not his base, x is.
So the base would be smaller?
So I'm saying when there's no lower down number showing, put a 10 or an e. That one has a lower down x.
So if there wasn't an x, you'd put a 10.
Yes, if there was an x, I'd put a 10. Let's see the one before that. See, that one had a 3. So those ones have. Everybody good on that? Good question. So if it's showing a base, well then great, that's its base. But if it's not showing a low down number, then you got to put one on there, 10 or e. All right, so we put one on there, lose the log, base stays the base, other 2 switch. Instead of e to the e stuff, it's kind of weird. Instead of e to the e stuff, these guys switch, and it's e to the 2, and the other e stuff goes over there. That makes sense? So now what is x? Solved by observation, yeah. Clearly 2. Don't need to do anything fancy. It's got to be 2. Good on that? See what I did? Base stays the base, the other 2 switch. All right. Too bad. Maybe it'd be worth our time. All right, let's try this one. So log base 3 and 9, 3x plus 6. Okay. So go ahead, do that first step. You know what to do. Well, why is it not showing? It's weird. Maybe it's lost connection or it's stopped tracking with me. Because I'm on a new page. Yeah, now you are too. There we go. So try that one. Let me let you get that one. All right, so we cross off the log. Base stays the base. Other 2, which means everything else, huh? That one already has a base showing, huh? So I don't need to stick in a base. He's already got a lower down number. Base stays the base. Other 2 switch when you lose the log. Instead of, come on. Instead of 3 to the 9, it's 3 to that 3x plus 6 stuff, and the 9 goes over there. Is that making sense so far? Is that good? Now, what did we learn? Was it last time? That when we solved when you got power things like that. What do you do? Yeah, make the bases the same. That means 3 squared, huh? Right? Now you can set the powers equal. 3x plus 6 is not 3 but 2. Set the powers equal. Solve for x. Subtract 6. What is that? 3x is negative 4. Divide by 3. Negative 4/3. We all good on that? So you make the bases the same, then set the powers equal, right? We're going to get new ones. Here's where we see what logs are really for. Real life, all the time, economic situations, engineering situations, banking, high finance, or engineering, architecture, they need to solve equations like that. It's a real life necessary thing for those kind of professionals. So you got to solve something like that. You got to get x alone. How are you going to do it?
Multiply by natural log.
Yeah, not multiply. Remember, that's not multiply. That's my toaster thing, right? But you're right on track. It's take the natural log of both sides. You realize there's no other way. Before I do that, think about it with me. What else are you going to do? Divide by the e? That's not multiplication. That's not e times 9x. That's e to the 9x. That's exponential. Not because of e, but because x climbed into power. That's what I mean, right? When x climbs into power, what in the world are you going to do? Now, we had that hokey method that we were like making the bases the same, but that isn't going to work here. You can't make the bases the same. So, really important. When x in power, take ln of both sides. Really important. Write that in your 3x5 card. So you want to put a brand new ln on both sides. Remember, we're not multiplying by ln, we're taking the ln. Like we're sticking both of them into an ln function. Right? Taking the ln of both sides. Okay, now why? Why is that so great? It's not going to be great unless you remember log properties. Remember that third log property. Remember what powers can do? They slide down to the front. Remember that? Remember the three log properties? Remember adding, two logs added becomes, or one log multiplied becomes two logs added. Remember divided becomes subtraction. And the third quality, powers can come down to the front. Remember that? That's the glory of the log. That's the greatest characteristic of the log, that they can dethrone powers. See how that power came down like that? That's amazing. You got to be a little bit amazed by that. Nothing else we have in the math curriculum will do that I know of. Will bring powers down. That's a big deal that thing just did that. That 9x is no longer in power, right? That's a big deal. Who's in power matters, right? They affect things. I'm spending all my free time as I drive from here to there listening to, I think I probably told you, the biography of Winston Churchill. I love all that time period. And who's in power? It was Churchill and Hitler, and they were facing off. It's funny, Hitler's a very funny guy. It's just interesting. I mean, funny, evil, but and he said he wanted to take over England, but he didn't want to kill them all like he did France. He wanted to make a peace treaty with them. He said he did. He wanted to get them to submit so he could then take Russia out. But he said, I like those Englanders, Hitler said, except for Churchill. Right? Because Churchill was a man. Churchill stood up to him and said, we will fight and we will never surrender. Anyway, leadership matters. Getting such and such out of power matters. I'm doing a little, I'm a wannabe history teacher, so I got to say that. Anyway, right? So that 9x comes down. All right, so remember that. You really have to remember that. It's hard, and I say it because it's hard to remember, because it's like, where'd the natural log come from? It's like out of the blue. You know what I mean? It's not going to occur to you naturally. So you got to write this note on your 3x5 card. When you have x in power, take the natural log of both sides, and then the power comes and it dethrones the power. It's a big deal to take a, if Churchill hadn't been in power, I'm not sure what would happen to England. It was good he was in power. So that takes that out of power. Now, ln of e, that's just 1. You can check it on your calculator. Just take my word for it. ln of e is just 1. So that's gone. So what does that mean we have? We just have, I can scribble it over here, 9x is ln 2. That's supposed to be just a regular 2. I'm writing it funny. There we go. And 9x is ln 2 because the ln e is just 1. And then just divide by 9. If I can squeeze that in there. Divide by 9, we're done. X is alone. It's ln 2 over 9. We solved for x. So what do you do when x is in power? Natural log of both sides. It dethrones the powers. It brings the powers down. Like that. That good? Questions on that? I swear I was trying hard to be on time and I got stopped on campus halfway across. I really am committed to being here. But my actions haven't shown it. All right, try that one. Try that one. So you got x in power. Try that one. So ln of both sides, right? ln of both sides. You got to get that 9x plus 4 out of power. I'll give you a second. Feel free to check with those around you, see if you're getting the same answer. Okay, you guys doing good? You good there? So natural log on both sides. I'll just squeeze it in, ln, and then the power comes down, right? So it's 9x plus 4 times ln e, ln 13. We good? Ln both sides, power comes down. Now ln e, that's just 1, so pretty much vanishes. So we just have 9x plus 4 is ln 13. ln 13 is just some number. We'll find it in a minute. Just let it be. You know, subtract 4. That 4 is outside of the ln 13, right? It's not going to be ln 9 or something. You can't. That's outside of the, this is like this. It's plugged into a function, right? So it's just 9x is ln 13 minus 4 is out there divided by 9. Squeeze that in. There it is. And you could hit, I don't know if they want a decimal. What do they want? No, they want an exact answer, so they want that. They want that exact answer means no decimal rounding. They want just that typed in. Exactly like that. Does that make sense? Is that good? Questions on that? So when x is in power, remember my Winston Churchill Hitler say, when x is in power, the power thing matters. Who's in power matters. What's going to get it out of power? Natural log of both sides, right? Natural log. Powers come down. Real important and not easy to remember. Yeah, Tim.
Okay, so if the base is always just e by itself, couldn't you do the whole exponential log switch?
Oh, you're right. You are totally right. You could bring in just one. I hope I don't confuse you by saying this, but you're right. That would be bringing in only one log, not two, but you're totally right. Yes. You could bring in one log brand new, the base stays the base, the other two switch, and you get the same answer in the end. Yeah.
Would it be the same if the base was 10? Could you do it with the log?
Yeah, bring in the regular log. Yeah, base stays base, so you could always do that, yeah. Yeah, now, the reason I show this is because sometimes they're going to put powers on both sides. And then that would work, because you can only lose one base with that whole trick. That's why I just show this. This will work for all those cases. So that's why I found students like one thing that works all the time, and so that's what this is. But you're right. Okay. That other thing will work. Maybe. We're almost at the end here. All right. Try that one. You see, somebody's in power. Hope you remember my whole history story, right? Somebody's in power, see the natural log at some point, but not quite right now. So let me write a note. First, get base with power thing alone, right? Meaning, get rid of that 5. Divide by 5 on both sides. You know what I mean? You've got to get the base to power thing alone before you do the ln. 6 over 5, isn't that 1.2, I think? On the right side in your calculator, 6 divided by 5. 1 1/5, so 1.2. Good to there. Now do the normal thing. Now it's ln to both sides. Power comes down. But you ever see what I had to do first? I didn't first do the ln. I first get the base to power thing alone. Right? See, that 5 was not involved in the base power thing. It was just separate. So get rid of that first. Get the base power thing alone. And then ln both sides. So ln both sides, power comes down. like that. ln e, you know, that's just 1. So then just divide by the 0.2, divide by the 0.2, and there x is a log. Right, it's ln of 1.2 over 0.2, whatever that is. Does that make sense? So get rid of anything that's in the front of the base power thing first, then ln both sides.
I want to be back into it.
Do they? Yeah, so they want that, exactly that. So they don't want a decimal. All right, for 2 minutes of class time here. All right, so this is one of these big old ones, you know, where they have the 5 parts, you know. Here's the original function, find the domain, now graph it, find the inverse, graph that. These are so valuable, so valuable. All right, so Roberto's here. He would love to do those with you, I'm sure. Go see him. His hours are there, right? All right, so let's do this. Let's do what we can. What's the domain of that thing? All reals, right? It doesn't have any problem areas. Remember, what are the 3 problem areas? Denominators, don't got that. Square roots, don't got that. Inside of logs, don't got that. Right? You clear on the 3 domain issues? Right? 3 domain issues for domain. There's 3 problem areas, like things you can't do, like putting tinfoil in the microwave, knives and toasters, right? Denominators cannot be 0. We don't have any. Square root, inside, we say inside, you've got to be greater than or equal to 0. Or log of any kind, natural log or regular, doesn't matter. Inside, we say inside, you have to be strictly greater than 0 instead of greater than or equal. We don't have any of that. So this one is all reals or negative infinity, positive infinity, whatever. It's got no problem areas. Okay, that part's easy. Step 2. Now, graph that thing. So can you graph that thing? What's the first step in graphing that thing? Horizontal asymptote. Horizontal, which is what? 3. That's the horizontal asymptote at positive 3. Right? Positive 3. All right, then make the XY chart. What am I going to plug in for x first? Yeah, I want to get through this and do the inverse at least. Plug in 5, because that makes x's little world 0. Right? You always make x's little world 0. So that'd be what? E to the 0 plus 3, which is 1 plus 3 is 4. So over 5. 1, 2, 3, 4, 5. Up 4 right there. Here's the dot. Do one more. Add 1. 6. E to the 1 plus 3. 2.7. 5.7. So e to the over 6 up 4. 5, 6. So 5 over 6 up 5.7. But right here. All right. Easy enough. There it goes. All right, so there's the graph. That good for that exponential graph? Am I going too quick? I just want to find the the inverse real quick before I let you go. So is that good to there? So there's the graph. Find those 2 dots. Now, let's find the inverse. Yeah, so go ahead. Find the inverse. And we're expecting the inverse to be some kind of log, huh? Because the inverse of exponentials are logs. So y equals e to the x minus 5 plus 3. What's the first step to find an inverse? Switch x and y. Just the x and y. Notice everything. This is where students get confused. Because there's 2 kind of switcheroos we do. I want to show you this. I know we're going over time here. Just real quick. Students get confused with the 2 kind of switcheroos. Realize we have 2 kinds. We have inverse function, just x and y switch. Everybody else stays put. That's what I just did. Right? Only x and y trading. The minus 5 is still where he was. The 3 is still where he was. Nothing else moved. That's one of the kinds of switcheroo. The other is when we gain or lose a log word, the base stays the base, and everything else switches. Students get those all convoluted with not enough practice. So you got to practice that. So, all right, now we're supposed to, so we switched x and y. Now how do you solve for y? What am I going to do to solve for y? Well, first get rid of that 3. So x minus 3 is e to the y minus 5. Now, how am I going to solve for that y? What am I going to do? The y's where? Where is the y's? Where Churchill and Hitler were. In power. The y's in power. So what are we going to do? Natural log, right? Did that occur to you? When the thing you want to get alone is in power, you got to take it out, right? You got to take it out of power. Hitler said to Churchill in a speech, and he said, one of us will flinch, or one of us will lose? And it was Hitler, wasn't it? He was sure it was going to be Churchill. All right, anyway, so we got to take it out of power. Somebody's coming out of power. Somebody's going to lose. So it's x minus 3 equals e to the, what was it? Y minus 5. And so natural log on both sides. Natural log on both sides. Right? And now what does that do? It dethrones the power. Y minus 5 natural log of e. Right? And natural log of e is just 1, so who cares? Add the 5 and you got it. And I'm already over time. Right? So does everybody see that? Plus 5. Y's alone. There it is. Thanks for waiting, guys and gals. I won't see you for a week. Be nice to the sub. And Wednesday, Thursday is your test. So I wish I had time to go over the practice exam with you. It's online, right? It's there. They're all Roberto will go over the practice exam with you. He's got them. Have a good rest of the week. Hope you do well in that exam, too.
Have a good week.
Just like the practice exam, I promise. Oh, I forgot to ask, if anybody wants to make money, $20 per test, you can go over and take a practice test. Over there, they have a new assessment test. They're trying to calibrate. They're paying people $20 to come take the math one, $20 for the English one, over in the assessment center. If you're interested, they'll pay you to come take it anytime you want, Monday through Thursday, like 8 to 5 or whatever. Assessment center.